Welcome again, everyone. Today we're going to shoot into a video which is going to be a tiny bit different than usual. It's not part of the main Complete Free Flutter course series which I'm doing on this channel. Instead, we're going to do what I call the Programming Essentials series. It's going to be the first video of that. And this is a series which is meant to appeal to everybody from all programming languages rather than just people working with Flutter. However, because my main language is Dart and I usually use Flutter, that's what I'm going to be using to illustrate the points I'm making today. And the topic today is going to be logical pixels. So once again, we're going to talk about logical pixels. This is something which I find really interesting. The first time I found out about it, I was a little bit confused because I didn't know what was going on. I had to do some research and find out what it basically is. But what is it? Well, let's find out. So again, this isn't meant for only people who know Flutter. So I'm going to give a really brief overview of the projects I have open. It's just an empty project. You can see on my emulator, nothing's running. And I just have my home screen. And in my home screen so far, I have a scaffold, which gives me details about the layout, and the layout builder, which helps me get, again, details about the layouts, the size of the layouts and that kind of thing. And then I just have a column here, and the column has nothing in it. Then on the side here, just to save myself some typing, I have an error apparently. I'll fix that later. I have a container with width, which is just something, as I said, save myself some typing. It makes a container which aligns my text in the center, and then I can have a leading text and a main text. And then I have just made the text a bit bigger and semi-bold so we can see it a bit more clearly. And what I'm going to do is inside my children in my column, I'm going to make a container with text, and I'm going to give this a leading of h, or sh for screen height, total screen height, and I'm going to give this a media query.of context.size.height. And what this does, media query.of.context.size gets the complete size of my screen from here all the way till here. And .height, of course, gets me the height. And then I'm going to say container with width, and we'll say screen width for SW. And then same thing, media query.of context.size.width, of course, to get me the width. And I'm also just going to put a quick sized box between these and give this a height of 10. This is just to give some kind of spacing between it. I'll give it another quick sized box, height of 10. And here I'm going to put a quick container with text, and I'm just going to give it a leading, so some kind of spacer and something to break it up. I'm not going to give it a second widget, just an empty string. And then we can have a sized box again, height of 10, container with text. I'll give this layout builder height, and we'll give this constraint dot height, and it should have been max height, and another size box. We're almost done here. Height 10, and a container with text lb width, so that's the layout builder width, and we'll have constraints.max width over here. So what am I doing here? My layout builder is going to give me just the size through the constraints here of the area I have, which in this case is from here till here, not including the black space, because I have my scaffold wrapped in a safe area to avoid these kind of notches here. Whereas on the other hand, my media query of context.size gets the total size, including everything, is the total size of the screen. So essentially what this is going to do is it's going to show me how big my screen is. And I have the emulator running here in my second terminal. I'm going to refresh it so all that stuff shows up. And now we can see it. So my screen height is 737 point whatever, width is 392 point whatever, and then not including the safe area, I actually have 713. Okay, so that's interesting actually, because if we look at the emulator I'm running, you can also see it over here, is the Pixel 3. But if I look at the Pixel 3's resolution, it has a resolution of 180 by 2160 pixels. But you can see that's not what I'm getting here. Here it's telling me that the larger one is, this top one, 737, which is obviously smaller than 2160. But it gets even more interesting because I also have this running in a Chrome tab. For anybody that doesn't know, with Flutter you can also make web apps. And I haven't refreshed it, but I have it running in this first terminal here. So I'm just going to hit Control R to restart it. And here, if I compare the two and put them side by side, I'm going to try to match them up correctly. Yeah, so I'd say they're matched up about the same, because I do also want to include the black area. Here it says my screen height is just under 700, so it is a little bit less. My width is 500. Well, this is as small as I can make it, so we're not interested in that. What's really interesting about this is if I enlarge this all the way, I'm getting a total width of 1920 and a total height of 981. But if I close all of this, close my Firefox, close this, right click and go into display settings, I can see my resolution is 1920 by 1080. So the complete resolution of my laptop screen is actually smaller than what my Pixel 3 should be. My Pixel 3 should be 1080 by 2160. Now, he does have the numbers the other way around than my laptop, but it should be evident that this should be bigger than this, right? But it's not. And the reason it's doing this is because of logical pixels. You can see that when my two screens are side by side, it's approximately the same. It's not exactly the same because, of course, this is an emulator and I can actually just resize this, which I think I've done a few times, which maybe is why it's not identical. Maybe I made it too small in the past. Maybe I made it too big. I don't know. But they are approximately the same when I have them at the same size here, even though the real resolution is quite different. And of course, you guys know an actual pixel is supposed to be the small square which makes up the image, and all those different pixels together make up the entire image. But you can see that's not quite what's happening now, because while this is your real pixels, it can be so complicated when you're a dev to figure out how big do I want a certain component, because all these different screens have different sizes. So then that's why logical pixels came about. Logical pixels are an attempt to kind of, sort of, not exactly make it easier for us to figure these things out. So logical pixels should be approximately the same for the same actual number of inches on the screen. So if I held my physical phone, so I can't record this, but if I hold my physical phone against my screen, it's about the same size as my emulator. In fact, I think it's identical, or almost identical. And even though my physical phone has many more pixels than my entire laptop, it's still gonna show that logical pixels to be the same so that I can build the layout more easily. This of course means that if I have a component from here to here, and in fact I can build one quickly, I can just make a new container and I'll give this a height of 200. In fact, let's make it 350, so it's approximately half of my screen's height. And I'm going to give it a color, and it can be anything, just so we can see it, colors.blue. And once this, I refreshed it in the other once this refreshes, we can see it's approximately half of the screen size. And if I go into my Chrome, it's also approximately half my screen size here as well. Now my Chrome, of course, has a tiny bit less logical pixels than my emulator. That's fine. But again, it's approximately the same size, so that when you build something, it should kind of look the same on different screen sizes. Now, I do keep stressing kind of, almost, these kind of words, because unfortunately, although these logical pixels do help us with our layouts, it's not exact. And a really good example of how this can throw us off is the iPhone. If we look at the iPhone 11, it has 414 logical width and 896 logical height. However, when we look at the iPhone 11 Pro, it has less logical width and less logical height. However, of course, you guys should know the iPhone 11 Pro is the larger of the two iPhones. And when we look at the resolution, so the iPhone 11 Pro has a resolution of 2436 by 1120, 25. And the regular one has 1792 versus 828. So you can see that even though we have a bigger screen on the iPhone 11 Pro, it does have less logical pixels. So as a result, it's not actually guaranteed to look identical on the different screen sizes. And this is why us Flutter developers use things like what I had. I have a media query of size.height to get the exact size, and then I can do something like divided by or multiplied by 0.2 to only get 20% of that. And then I can use that instead of using a strict number. Like instead of saying here 350, I could use media query of context.size.height times 0.5 to get half the height instead of just approximately half. And you can see when I do this, now, apparently my screen sizes don't match up. Maybe it's not including this. It's because of the safe area, isn't it? Now if I make it the same size, it should be the same size, but it's not identical still. But it's close enough. But the point I'm trying to make is obviously if you do use this media query of context.size.height, or if you use constraints.maxHeight, you can make things look the same way. However, you do also need to do it in the size box. And this is exactly why these don't look identical, because my spacing, my size box, I've hard coded that. So that's throwing off the calculations. And the same thing is happening with my text, because I have not wrapped these text widgets in a container, and the container is taking the minimum height. So the container is taking the height of my text. And you can see the text is slightly different between Chrome and my Pixel 3. So there's that. So we can, of course, do things to mitigate this. If we do follow coding best practices, doing things like wrapping our size boxes in a strict height, or instead of using a actual number here, using something like this multiplied by, I don't know, 0.01 or something like that, whatever space we want. If we wrap our text widgets in a container as well, and actually give the container a height rather than just leaving it like this, we should be able to eliminate the differences between the device sizes to a certain point. We will still get into issues because the aspect ratio of my Pixel 3 is quite different than the aspect ratio of the iPhone. So I'm not going to look it up for you guys right now, but the iPhone 11 and 11 Plus are taller than most Android devices. So as a result, even if I use all of these kind of calculations for my Android phone versus for my iPhone, it's not going to look identical. The iPhone just has more height than my Android phone does. So that's a consideration. And different Android phones might have different aspect ratios as well. That aspect ratio is going to throw off your calculations. It's going to make things look different on different devices. But still, logical pixels. It's something that can help you calculate the correct height. but at the same time, it's not the be-all, end-all. So just be aware of that. Okay guys, that's all I have for you this time. So until next time, myself with Vidius, I'm out.